Elementary Algebra, Final Assessment 2, Review, Questions 7 through 10, Outcome 2, Solving. In this section, you are asked to use the multiplication principle of equality to eliminate the fractions or decimals, then solve. If the equation contains fractions, we multiply both sides by a number that will clear all of the denominators. We could multiply both sides by any multiple of the denominators. However, using the lowest common denominator or least common denominator results in the simplest equation. Let's clear the fractions in problem number 7. We look at the denominators of the fractions present. We have a 4 and a 3. To clear these fractions, we need to multiply by the lowest common denominator. The lowest common denominator between a 4 and a 3 would be a 12. So we're going to return and multiply both sides of this equation by 12. So we're going to have 12 times our 5/4 x plus 2. On the other side, we'll multiply by 12 as well, so we'll multiply a 12 to a 1/3. So let's go back and distribute these. So a 12 times a 5 would equal a 60 over a 4. The reason we have it over 4 is if you look at the 12 in this equation, it's over a 1. We distribute the 12 to the numerator's position. We distribute the 1 to the denominator's position, so we end up with 60 over 4, carry down our x, plus a 12 times a 2 to create 24. On the other side, we would have a 12 times a 1. Again, just think of putting that 12 over a 1, so 12 times 1 to create 12, 3 times 1 to create 3. Now let's simplify these fractions. 4 goes into 60 15 times, so this creates the problem 15x plus 24 equals 12 divided by 3 is 4. Now we've created a problem where we've cleared the fractions, and we're ready to continue and solve for x. Let's start by moving that 24 to the other side. We're going to sum to this a negative 24. Whatever we do to one side, we must do to the other side of the equation. So we'll sum a negative 24 to both sides. We come up with 15x. The 24's cancel down to 0 equals a negative 20. Last step here would be to move the 15 off the x. We'll do this by dividing by 15. So we'll divide both sides of the equation by a 15. That means the 15's clear. We're left with x on this side equals a negative 20 over 15. We're not quite done though. We want to go ahead and reduce down the fraction. If we look at 20 and 15, they're both divisible by 5. So if we divide a 5 into a negative 20, it results in a negative 4. A 5 into a 15 results in 3. So our final answer is going to be negative 4/3. In question number 8, let's continue with the same instructions and clear the fractions. In looking at question number 8, before we begin, let's go ahead and clear the parentheses by distributing the 1/4 through the parentheses. This results in 1/4 y minus 3/4 equals 5/4 minus y. Next, we want to multiply by the lowest common denominator. In this case, each of our fractions have a 4, so our lowest common denominator will be that 4. Let's go ahead and distribute a 4 to each term. So distributing a 4 to 1/4 results in 4 over 4y minus a 4 to the 3/4 resulting in a 12 over 4. On the other side, we multiply that 4 through again. 4 times 5 is 20 over 4 minus a 4y. Let's reduce these fractions down. 4 over 4 is 1, so we end up with a 1y, or just y, minus 4 into 12 for 3 equals 4 into 20 for 5 minus 4y. Next, we want to move one of our terms. If we look here and look at the terms involving our variables, if we move the negative 4y to the other side, it will create or result in a term with a positive value. So we're going to add a 4y to both sides, plus 4y. This results in a positive 5y minus 3 equals 5. Next, let's move that negative 3 to the other side. We can do that by adding a 3 to both sides, plus 3. This results in a 5y left on the left side. That 3 goes down to a 0. Looking at the other side, we end up with 8. Lastly, let's divide that 5 out to move it away from the y. So divide by 5, and we end up with y being equal to 8/5. In question number 9, we're going to continue on with the same instructions, but in this case we're going to be clearing decimals in an equation. The multiplication principle can also be used to clear decimals in an equation, because multiplying by a power of 10 will cause the decimal point to move to the right. We can clear decimals by multiplying both sides of the equation by the appropriate power of 10. The power of 10 we use depends on the decimal number with the most decimal places. Let's start on question number 9 by distributing to clear the parentheses. We'll distribute the 0.2 to the 60. 0.2 times 60 results in 12. Go ahead and carry down the 0.4x as that we've not yet used it. Now we want to distribute this 0.3 through the parentheses. A 0.3 times 60 results in 18. A 0.3 times x results in a plus 0.3x. Next, we want to clear our decimals. We do this by looking at each of our decimal numbers and looking at the place in which they carry out to. In this case, we have a 0.4 and a 0.3. In both cases, they carry out to the 10th place. Because they carry out to the 10th place, we'll multiply both sides of the equation by 10, making sure that that 10 is being distributed to each individual term. A 10 times 12 results in 120. A 10 times a 0.4 will result in a 4, or 4x. A 10 times 18 will result in 180. A 10 times a 0.3 will result in a 3x. Going back and looking at the same section again, this 10 being distributed to the 12. If you notice, what's actually happened is the original decimal place moved over one place, adding a 0. In distributing the 10 to the 0.4, our decimal place moved over one place, resulting in a 4. In the 10 to the 18, again, decimal place just moved one place, resulting in a 180. And the 10 to a 0.3 resulted in the decimal place moving one place, resulting in a 3. Another way to remember this is that if you multiply by a 10, it moves one place, or essentially a 10 has 1 0, so move all your places one place, or the same as that 1 0. If we had to multiply by 100, there's 2 zeros in 100. The decimal place would move back 2 places in that case. If you had to multiply by 1000, the decimal place would move 3 places. There are 3 zeros in 1000. Alright, now that we know this, let's go on and continue to solve our problem. We have a 3x and a 4x. We'll move the 3x to avoid creating a negative sign. So we'll do that by subtracting a 3x off both sides, minus 3x. That 120 carries down. We end up with a plus x over here equals 180. The 3x and the negative 3x resulted in a 0. Now we want to move this 120 to the other side. We'll come back. We'll subtract both sides of the equation by 120. This results in x being equal to 60. In question number 10, we're still continuing with the same instructions, clearing the decimals in the equation. We look at the decimals. The 0.4 goes out 1 decimal place to the 10th place. The 0.1 goes out 1 decimal place to the 10th place. The 0.8 the same, 1 decimal place. The 10.9 1 decimal place, and the 0.2 1 decimal place. Therefore, we'll multiply both sides of the equation by a 10. So we'll come back in here and we're going to be sure to distribute a 10 to each of the individual terms. So we'll distribute that 10 to the 0.4. That means that the decimal place just moves over 1. So this results in a 4. Minus, now we'll distribute that 10 to the 8.1. Moving the decimal place over 1 place results in an 81y. Distributing that 10 to the 2.8 results in the decimal place moving 1 place, resulting in a 28y. On the other side of the equation, we multiply the 10 to a 1, which results in a 10, minus a 10.9 times 10, move the decimal place over 1 for a 0.9y, minus, now we take that 10 and distribute it to the 0.6, which results in a 6. Next, we want to simplify both sides of the equation by combining any like terms that are present. Looking at the left side, we see that the negative 81 is like the negative 28, so we will combine these two. This results in a 109y. Carry down the minus 4 from above that we haven't yet used. Now we look at the other side of the equation. Our like terms here are going to be our 10 and our negative 6. They're opposite, so we will subtract them. So a 10 minus a 6 results in a 4. And then we will carry down our 109y. If we stop here and look at both sides of the equation, they're alike. They're the same. This means it doesn't matter what number we plug into y, it's going to result in the same value on both sides of the equal sign, creating a true statement. All real numbers in this case would work in this equation. So your answer will be all real numbers.